This question is on light, and you have a diagram here represent the surface of a transparent liquid, the liquid being the gray shaded region. Two light rays are traveling within the liquid, so you have it here, the light rays traveling from a denser medium, which is the liquid, towards a less dense medium. That means to say, since it's traveling from a denser to a less dense medium, you should actually consider total internal refraction if the two conditions are met. This is one of the conditions. I hope you can still remember. The other condition is to check whether the I is greater than C. Alright, having said that, there are two diagrams here, and you must first of all be very careful. The angle 50 over here, that is not your angle of incidence. Always remember, the angle of incidence here must be between the incident ray and the normal. That is your angle of incidence. So in this case, 90 minus 50, that will be 40 degree. And in this case here, that will be 35 degree. Now, the next thing we need to consider is the ray after hitting at this point of incident. So let's look at the diagram on the left here. You can see that there's only a reflected ray, and that's the only ray. That means to say 100% of the light is being reflected. That should give you a hint, or that should tell you that this is total internal reflection. All right. Then the diagram of the right is very important, because you know that after this point of incident, the ray is along the boundary. That is a very important point to you, or hint to you, and that means to say your R, angle of refraction, is 90 degree. So if you understand this diagram, very important, that means to say this angle of incidence, which is 35, is also the critical angle for the liquid. Now, even if they give you this reflected ray here, will be a weak reflected ray, you should be focusing on this. This is definitely, if I have these two ray here, you should not be focusing on this. You should be focusing on this ray that's along the boundary. This just shows that because the surface, the boundary is still quite smooth, a little bit of light will be reflected. So you should know that the I is equals to C just because of the presence of this ray. So if you understand this, straight away you'll know that you should be focusing on this. The one on the left is just like a decoy like that to confuse you. So if you know I equals to C, and you can use the formula N equals to 1 over sine C, and you're going to find your refractive index N. So I will substitute the C with 35. And you work it out, it will be 1.74, and round off to 2 sigfig 1.7. That will be the refractive index of the liquid. All right, so I hope you understand now. Thank you.